Oh, yeah. Y'all know who it is coming up next. He's an immortal cannabis wizard and the co-host of the What's Good podcast. Here drop timeless knowledge and truth bombs alike on the globally clueless masses. Coming up to the stage is the Count himself, Mathieu St Germain.
Thanks, Rico. Happy Monday, everybody. I've got a great one today. This one is just more excitement about psychedelics. There has been a breakthrough study that discovers that psychedelics breach our neurons. What does that mean? The clinical evidence for using psychedelics to treat major depressive disorder, PTSD, addiction, and other mental health conditions is building. But despite the growing pile of data, we do not know just how psychedelics might be helping. One theory behind conditions like depression is that they're caused by the breakdown of connections between brain cells. Researchers have found in multiple studies that psychedelics can increase connections between cortical neurons. Specifically, they spark the growth of the tendril-like antenna on neurons called dendrites. The dendrites catch signals from other brain cells and link these neurons together. In theory, this may mean new connections being formed and strengthened, helping the brain to rewire itself. Now, surprising new research out of UC Davis may have finally explained why psychedelics spark dendrite growth when other drugs which activate the same targets in your neurons do not, and this may be the key in their therapeutic value. The first clues about how psychedelics may be physically altering neurons came from ketamine, which researcher Ron Duman's lab at Yale showed could promote dendritic growth in mice. Subsequent research tied this growth to ketamine's antidepressant effects. In 2018, David E. Olson's lab at UC Davis published a paper in Cell Reports showing that a variety of psychedelics, like pretty much all the ones you've heard of, he said, were effective at promoting the growth of the cortical neuron dendrites. Those findings have since backed up and been expanded upon by multiple labs and in multiple models, including neurons in a dish, in fruit flies, in mice, and now in 2021 pigs, and next will be humans. Here's the thing, though. All the research led to very odd realizations. If psychedelics spur neuronal growth, why is it that many other drugs that interact with the same receptors, including serotonin itself, do not? And the goal of this study, Olson said, was to solve this enigma. Despite the many mysteries of how psychedelics do what they do, there has been a long consensus among scientists that one particular receptor on brain cells called 5-HT2A is the key. The natural home for the neurotransmitter serotonin, 5-HT2A, is activated by a variety of pharmaceutical drugs used to treat depression, migraines, and psychosis, as well as all of the popular and superfun psychedelics like mushrooms, LSD, MDMA, DMT, and ketamine. There is a ton of evidence that suggests that activation of the 5-HT2A receptor is what leads to the hallucinogenic effects of the drugs. Olson, director of the UC Davis Institute for Psychedelics and Neurotherapeutics and co-founder of Delix Therapeutics, reported. Now, this raises the question, since other drugs are hitting the receptor and they don't cause either the hallucinations or the neural growth, what is special about psychedelics? New research by Olson and his colleagues published in Science showed that psychedelics, unlike serotonin, appear to act on the receptors contained within brain cells, not just on the receptors outside. So what's happening is that these psychedelics novelly are actually going inside of these brain cells and spurring them to grow and connect and causing a higher level of patterning. I'm breaking down some of the technical stuff for all of us here. Now, what they have also found was serotonin does a very poor job of crossing the membrane of the cortical neuron, getting inside and activating those internal 5-HT2A receptors. But psychedelics like psilocin and DMT are greasier than serotonin, which allows them to slip through the membrane and activate the receptors. The team tested their theory by artificially helping serotonin get into brain cells. Using methods like jolts of electricity and transport proteins to get serotonin into the cell, they were able to activate the interior receptors and cause neuron growth in vitro, like what they saw with psychedelics. When they tested it on mice, they saw both neural growth and antidepressant effects in the animals. It seems to overturn a lot of what we think should be true about how these drugs work, Cornell neuroscientist Alex Kwan, who was not involved in the research, told Science News. Everybody, including myself, thought psychedelics act only on receptors that are on the cell surface. Olson says that studies that knocked out these 5-HT2A receptors have found that it eliminated both the hallucinogenic but also the majority of the therapeutic effect of the psychedelics. They go on to say that finding out more about these basic pharmacological actions can help in implementation and development of targeted psychedelic drugs. And they're thinking that possibly drugs that are more targeted may have higher efficacy. Though I'd like to add that what I've seen clinically with most of these studies is when you take away the psychedelic effect, you oftentimes lose a lot of the therapeutic effect, like they were saying earlier in the story. So I'm really looking forward to batting this one back and forth. This is Mathieu St Germain, your friendly neighborhood immortal for the High at 9 News.
Friendly neighborhood immortal.